All right, day 2 of chapter 5, section 1 on sample space and probability. Okay, in the first day of this lesson, we talked about sample space and figuring out how many total possible outcomes can exist for an event or a series of events. Now, the application to probability is now going to compare a set of favorable outcomes, and that's just that may be a vague term right there, and that's on purpose. Basically, I'm going to analyze how many different ways a sought after event, or one that I'm at least interested in, compared to the realm of possibility. So for instance, if I wanted to know what's the probability of me rolling, say, an even number on a single die, I'd want to know first, how many possible ways are there for me to roll a number on a single die? And there are six different sides. And then I would want to compare that to the number of favorable outcomes. In other words, in that case, if I'm looking for even numbers, how many even numbers exist on a single die? That would be the numbers 2, 4, or 6. Nothing smaller, nothing greater. So there would be, in that case, 3 favorable outcomes out of the 6 possible. That would be how I'd find the probability. And the last thing I would do there would be simply simplify or reduce that fraction, whatever I had. So in that case, the 3 out of 6 possibilities could be reduced to a 1 and 2 probability, or converting that into a percentage, a 50% probability of me rolling an even number. That is the application of probability. And that's a pretty simple case right there. Obviously, it can get a little bit more complicated. And we illustrated that with using a deck of cards and drawing an ace out of it. But that will be essentially how we're breaking this down. Basically finding 2 different items. First, total possible outcomes given a certain event. And that's what sample space, yesterday's lesson, was about. And then 2, finding out and counting the number of favorable outcomes, or whatever it is that I'm analyzing or comparing. Okay, so let's apply that to an example. All right, so our first example today, we are given a 4-question quiz, true-false questions. And you might have experience with this. Maybe you sit down for a quiz and you have absolutely no idea what's going on, in which case you are blindly guessing on this quiz. Okay, so you might be curious as you are blindly guessing on this quiz, what are the odds, what's the probability of me doing well on this quiz, or really bombing it and getting every single one wrong? Okay, now that's part of what probability is about analyzing. So in this case, we're randomly guessing, so there is no prior knowledge. This is a pure guess, all right, on a true-false question, and I have 4 of these questions. Now, these are the 2 different things I'm going to find probability for, but before I apply these guys, the very first thing I'm going to want to know, again, there will be 2 questions ultimately I'm going to ask for each of these types of examples, but the first of that question is going to be, what is the size of my sample space? How many total possible outcomes can exist on this 4-question true or false quiz? And that is that string multiplication that I've described in the previous lesson about using sample size. So how many events are existing here? Okay, similar to like flipping a coin twice, right? Which is what we did in that one example yesterday, where I'm multiplying the number of outcomes for each of those flips. Here I have 4 questions. Each of those 4 questions has a true or false possible outcome. So if I want to figure out the total number of ways I can fill out this quiz, I would simply take the number of outcomes for question number 1, which would be 2, times the number of outcomes for question number 2, which again would be 2, the number of outcomes of question 3, again 2, and the number of outcomes of question 4, 2. So in order to find out what the total number of outcomes would be, I would simply do 2 times 2 times 2 times 2, 2 to the 4th power. If you're to do that in a calculator, you would end up with 16. There are 16 different ways for me to fill out this quiz, this 4-question true-false quiz. Okay, now that's a relatively straightforward one. The only thing that would change if, like, say this was a multiple choice question, if there were like 4 options for each question, then your number of outcomes for that would be 4 instead of the 2. Again, it can get more complicated depending on the scenario. So just be very careful about analyzing what events are happening. On a 4-question quiz, there were 4 events happening. Each of those events had 2 different outcomes. When I multiply them all together, we got 16 different ways that this quiz can be filled out. Okay. Case in point, an example of one of the ways that test could have been filled out, I could have answered true on all the questions. It doesn't matter whether or not I got them right. That's just one of the ways I can fill that quiz out. I could have marked them all false. I could have alternated them in like true, false, true, false. I could have gone true, false, true. Okay, there are lots of different ways. There are, in fact, 16 different ways to do that. And that's just the fast way to quickly find the sample space, the size of the realm of possibilities. What was the value in finding that number? That's going to end up being the denominator when it comes to probability. Okay, the realm of possibility, the total possible outcomes in this case for my quiz will be compared to 16 possibilities. Okay, so now I'm going to analyze the numerator aspect of the probability, finding out the number of favorable outcomes I'm looking for, the part that I'm analyzing. So for part A, I'm trying to figure out how many different ways I can get exactly 2 correct. Okay, exactly. Now pay attention to that word exactly 2 correct, because it doesn't matter which 2 I get correct. I could get the first 2 questions right. I could get the last 2 questions right, the middle 2, alternating, doesn't matter. But how many different ways can I get exactly 2 correct on this 4-question quiz? We'll count that in a second. But before I jump to that, I want to talk about the wording on part B here, where it says the other one I'm going to be analyzing will be getting at least 3 correct. That term at least, and you'll come across some that say at most, or some other kind of wording or phrasing there. We have to be careful with those. It's easy enough to interpret exactly 2 correct. That means I can't get 1 right, I can't get 0 right, can't get all 4 right. I have to get exactly 2 correct. In this case, at least 3 actually gives me a range of possibilities, because I could get 3 correct. 3 is at least 3. But I could also get all 4 questions correct, because 4 is also at least 3. Okay, so that's just something we have to be aware of with that, and that will change how we count those possibilities. So let me jump to whiteboard at this point. Okay, now for the record, on your solution sheet that is also uploaded onto Google Classroom, I'd have a full breakdown of all 16 different ways that quiz could be filled out. For right now, I'm just going to focus on these specific examples. Namely, part A here says, how many different ways can I get exactly 2 correct? So for that, I will use this green marker to represent correct solutions and the red marker to represent incorrect solutions. So if I have 4 questions on this quiz, let's count the number of ways. And this is just mostly going to be an illustration on how to figure out the specific ways it can happen. What we're really only going to care about ultimately is how many ways it can happen. But anyway, if I want to figure out one of the specific ways how it can happen, for instance, I could get questions 1 and 2 correct, but then get questions 3 and 4 wrong. Okay, so that could be my 4 questions right there, getting questions 1 and 2 correct, 3 and 4 I got wrong. In this case, this is an instance where I got exactly 2 correct. This would be one of the possible ways I get a favorable outcome. But there are different ways I could get exactly 2 correct. Now, I'm just going to methodically go through how I would go about doing this, because again, this can be tedious, right? So let's first talk about the ways I can get the first question right and then get a second question right somewhere in there. So let's say I get the first question right and then the third question right, and then I get the other 2 wrong. Okay, basically I took that guy and I slid it over 1 more slot. Still got 2 right here. This one I got like alternating ones, right? Well, I could also get the bookends correct. I could get question 1 right and question 4 right. But then I missed the middle 2. Still got exactly 2 correct. And this was just me kind of working through getting that first question right and sliding that guy over. Now, I can't miss the next 3 because again, I got to get 2 correct at least. So that's my set of solutions when I get the first one right. Well, I don't necessarily have to get the first question correct. What happens if I get the first question wrong? Okay, so I'll keep going down this way. Let's say I get the first question wrong now, but I get the second question right and the third question right. I would have to get the 4th one wrong again to get exactly 2. Okay, well, let's say I miss the first question again, but now I get the second question right, and then the fourth one right, just to kind of show you methodically how I'm going about doing this. These three right here represented me getting first question right. Those are the only three possibilities with me getting question one right. That's all that can happen because I can't slide this guy over further, right? Down here, now I've got the first question wrong, okay? And now if I get the second question right, I slid this second one over. And you may be wondering, like, could I loop this guy back around into front for another option right here? Well, that would end up being a repeat of this guy, right? So these are the only possibilities here that I can get for getting the first question wrong and the second question right. Okay, well, what happens if I get the first two questions wrong? And I get 3 and 4 correct, the last two correct. Okay, great. There's no other way to rearrange those guys. And if I were to slide this guy back up front, then I'm back at that solution. Okay, this now has encompassed all the different ways I can get exactly 2 correct. Okay, and that was just mostly an illustration to kind of show you how I would go through the tedious process of actually creating each of those instances, right? Technically, this is not the answer to the question. This just was simply the sample space of the different exact ways I could fill out this quiz and still get exactly 2 correct, whatever the true or false possibilities may be. So how many different ways can I get exactly 2 correct? There are 6 different ways that can happen. There are 6 ways for me to get exactly, write this out, get exactly, and the key term there was exactly 2 correct, or 2 right? Because there are lots of different ways I can fill out a quiz that I get more questions correct, or only 1 question correct, or even none correct. But in this case, I'm on to find out exactly 2 correct, all right? So back to what the question was asking for. It was asking me for the probability of this result. So how do I solve for the probability of this? So again, the way I figure out probability, and I'm going to get you introduced to this notation. Okay, P and then a parentheses. This P stands for probability, and it's taking the probability of whatever's inside the parentheses. In this case, getting 2 right on my quiz. Exactly 2 right. Not 1 right, not 0 right, not 3 right, not 4 right. None of those. Exactly 2 right. So that's the notation you're going to see for probability. You just get used to that. I'll deal with that a little bit more in just a minute. So in this case, I'm going to end up with a fraction. On the denominator of that fraction, this will represent the total possible outcomes in this realm of possibility. Being this 4-question quiz, how many different ways can I fill it out? That's what we figured out first. Okay, that was finding the sample space. In this case, that was 16 possible outcomes, 16 total ways to fill out this quiz. This is the full realm of possibility. Well, however many I may have gotten right, there are 16 different ways I could have filled it out. On the numerator, this was the favorable outcomes, specifically how many different ways I could get exactly 2 right, the part inside the parentheses. We just counted that, and we ended up with exactly 6 ways to do that. 6 favorable, or in this case, 6 of getting exactly 2 right. We'll call it favorable just for the sake of the terminology here. 6 favorable, again, for us just means how many different ways could I get exactly 2 right? There were 6 ways out of 16 total possible. So how do this technically right here would be my probability, 6 over 16. Now, for the record, that can be reduced. 2 goes into both those values, and I would end up reducing that to 3 out of 8. And that would be the final probability. If it wanted you to compare that with, say, a percentage, I'll remind you that all fractions are technically division problems. So I could do that in the calculator by doing 3 divided by 8, which would give me this decimal. Okay. And it makes sense that it's between 0 and 1, because like I said, all probabilities are between 0 and 1. So we'll get decimals. How would I convert this to a percent? I would take that decimal point and move it to the right 2 spaces So in this case, 3 over 8, a 3 over 8 probability would be a 37.5% chance of happening. Okay, so let's try something else now. Part B of this same example. Now we're asked with this same 4-question true-false quiz, what's the probability of me getting at least 3 correct? At least 3 correct. So for this, again, I'm going to use the fact that how many different ways, how many total possible ways can I fill out this quiz? That's still 16 in this case. But now I want to count the number of ways to get at least 3 correct. At least 3 correct, which means I could either get 3 correct or 4 correct. Both of those values, I can't get 5 correct on a 4-question quiz, okay? But those would be my 2 possibilities in this case. So let's figure out the sample space. Well, if I got 3 correct, I could get the first 3 questions right and get the 4th question wrong. And then what I'll do here is I'll just slide that 1 incorrect response throughout this possibility. So for instance, I could get the first 2 questions right, and then the 4th question right, getting the 3rd one wrong. I could have gotten the 2nd one wrong in this quiz and gotten the 1st, 3rd, and 4th correct. See, I'm just kind of sliding my way down here. Or I could have missed my first question and gotten the last 3 right. And that's it. There are 4 different ways for me to get 3 correct. Now, how many different ways can I get all 4 correct? Well, if I get all 4 correct, that's simple enough to write that out. And then that's it. There are no other way to rearrange that. Just because I got that one right, just moving that right answer, it doesn't work that way. Getting all 4 right is getting all 4 right. Okay, there's no other way to do that. So there's exactly one way to get all 4 correct answers. There are 4 ways to get 3 correct. So in total, that means I'm going to have 5 ways to get at least 3 right. There are 5 ways to get at least 3 right. And again, that operative word there was at least, that operative phrase rather. Okay, so again, how do I apply this to probability? Well, for the probability of this, I'll rewrite this using an inequality. Okay, so probability here would be getting at least or greater than or equal to 3 correct or 3 right. Okay, that's a way I can write it with an inequality symbol. This just says the probability of getting at least 3 right. So in order to solve that, again, I'm going to get a fraction. The denominator was the total number of outcomes of different ways to fill out this quiz. That is still 16 total ways to do it. For the numerator, or the favorable outcomes, or getting at least 3 right, we just solved that to be 5 different ways to do that. 5 favorable ways to fill that out. And there is my probability. This one does not reduce. So 5 over 16 would be my actual final fraction here, my probability. If I wanted to find out a percent, I would take 5 and divide it by 16 and would spit out that decimal, 0.3125, move the decimal twice, and that would also equal 31.25%. So if you were wondering, if you were blindly guessing on this quiz, what's the probability that you get at least 3 right, at least get a 75%? You have basically a 1 in 3 shot of getting it. Okay. All right, let's move on. So now we're going to talk about another strategy about solving probability, and that has to do with complement. So I'm going to try and spend just a little brief moment on this. I think I'm going to skip the examples. I'll let you check out the examples on the solution sheet. Instead, I'm going to just focus on the theory part of it here. Probability is something called complement. Now, complement is not like, in this case, the mathematical sense, is not like nice things said about you. All right. All of you are deserving of nice things being said about you, but compliment with an E, compliment that are nice things being said is spelled with an I. Compliment with an E refers to a mathematical term. And in this sense, it refers to basically the remainder or the leftovers of something. Okay. So for instance, talking about the compliment, if I tell you, and this is something that most gamblers should probably think more about before they go betting all their money, definitely something for you to consider before you go betting all your money on something. If there is a 10% chance of something happening, okay, the complement of that would be to say like, all right, well, that means that there is a 90% chance of it not happening. Okay. Basically, complement says like it's the remainder or the leftover, or in that case, the inverse of that statement. Okay. So for instance, if I tell you there is a 20% chance that the Seattle Seahawks win the Super Bowl, that implies that the complement would be, well, that means that there is an 80% chance that they do not win the Super Bowl. Okay. That's how that works. Okay, complement is similar, just simply the other piece. Algebraically, it's shown with this, where you say like, all right, whatever complementary piece is 1 minus whatever the regular piece is. Another way you could rearrange this algebraically would be take that guy and add it over here. So in other words, I would just simply say like, all right, again, if there was a 20% chance that the Seahawks won the Super Bowl, well, 20 plus 80, 20% plus 80% would get me back to that 100% possibility, representing all the different possibilities of who wins the Super Bowl. Okay, so just be aware of this kind of notation. Again, the P parentheses refers to probability, and then whatever's inside the parentheses just represents like some event that's happening, whatever event, however complex it may be, whether it's just flipping a coin or we're talking Super Bowl odds or something like that. Okay, so P of A talks about the probability of A. The notation you want to be aware of is this little bar on top of whatever A may be. It will not always be A. It could have words and stuff there. But that bar refers to this term complement. Basically for us, the simple part of it is just simply not A. Okay, so if P of A is the probability of A happening, P of the complement of A refers to A doesn't happen. It's one of those two things. Okay. So again, using that example, if A is Seattle Seahawks winning the Super Bowl, complement A would simply be they don't win the Super Bowl. Pretty simple. Okay. All right. So the example, the illustration I give you right here is that what if I'm rolling a single die, like just a single die, and it said, what's the probability of rolling a 3? Well, there's only one side of a die that has a 3 on it, so there's a 1 in 6 chance of you rolling a 3. That would be the pure probability of rolling that. Adding in that little bar now refers to the complement of that. So what's the complement of rolling a 3? Simply rolling anything else. Okay, it doesn't require that I list all those other options out. It just represents that other negative space, so to speak. Okay, so what's not rolling a 3? Well, it's small enough, so I'll just list it out. Rolling a 1, 2, 4, 5, or 6. Okay, so if I count those possibilities, I can get to this result that there is a 5 in 6 chance of me not rolling a 3. Another way to think about it, and it doesn't really give you a whole advantage to use complement here in this case because it's a really small sample space. But when the sample space gets really large, like in the hundreds or thousands, right? Counting the number of ways becomes a very tedious process. So simply put, just figuring out what's left over is a much simpler process. For instance, if there was a 1 in 6 chance of me rolling a 3, how many other ways are there to not roll a 3? Well, if there's a 1 in 6 chance, that means that the other 5 ways would simply be not that result or the complement of that result. It's a fairly basic concept, but it is powerful when it comes to solving these probabilities, because in a lot of cases, simply solving for the complement of something is a lot faster than it is for solving the regular probability of something. And you want to save yourself work. It's basically like finding a little shortcut into how much do I actually have to count. So I'll briefly talk through both these examples. I'm not going to perform them. They'll be on the solution sheet if you want to see those. So for instance here, what is the probability that if I roll 2 6-sided dice? So this is a very common scenario when you're playing board games at home and stuff, right? You're playing a board game and for whatever reason you want to take the time to figure out your probability of, will I not land on this square? Do I want to avoid this? Do I want to land on this specific one? Whatever it may be, okay? Pretty common thing you're probably used to. But anyway, what's the probability that I do not roll a 6? Okay, so first let's figure out the actual size of the sample space. If I'm rolling 2 6-sided die, technically there are 2 events happening. Rolling die number 1, rolling die number 2. How many outcomes are possible for each? 1 through 6, 1 through 6, 6 times 6, 36 different combinations of numbers. That might be deceiving. Some of the combinations are the same, but the dice would kind of be their own little objects. Okay, but 36 ways I can roll dice. Okay, and when I'm talking about sum, I'm talking about adding those dice together. Again, typically like a regular board game. All right, so when I'm asking ways to not have a sum of 6, right? Now there are 36 ways I can roll these dice. There are only a few of them that are going to involve adding up to 6. It's a lot easier to count that space than it would be to count all the other possibilities. So what is the probability of me not rolling a 6? Well, in this case, it actually may be easier to figure out, like, well, let me just count the number of ways that I can figure out how different dice add up to 6. In fact, what you'd find is that there are only 5 ways to have 2 dice add up to 6. Out of the 36, and it's a lot easier to count to 5 than it is to 31. It's not impossible. It just takes a lot less time. Okay, another way you'll see it, again, using these inequalities. What was the probability of the sum of my 2 dice being less than or equal to 9? Okay, this is where it may come in handy to understand your extreme possibilities of rolling 2 dice. What's the smallest number I could roll? Well, I could roll 2 1s, so I could roll a 2. Right? I could roll 2 6s. That would be the maximum I could roll, and that would be 12. So when I'm talking about what is the possibility of me rolling a sum less than or equal to 9, there are a lot more possibilities less than 9 than there are of possibilities bigger than 9. Okay, so the example of the complementary space here, instead of saying what's the possibility of rolling something less than or equal to 9, what are the possibility of me rolling something just simply bigger than 9, like 10? Or 11 or 12. And you'd find that that's a much smaller space to count, a lot easier space to count than it would be to figure out all of this range of values. Okay. So again, you can check out both of those individual solutions on the solution sheet that's uploaded to Google Classroom. But for right now, let's just end our lesson there. So let me stop recording.